All right, up on the board, you are looking at the calendar for the remainder of this week and into next week. Today, we finish up our stoichiometry or introduction to stoichiometry stuff with the last type of problem that appears on that problem set. If you were following along what we were doing towards the end of class yesterday with the changing mass into moles kind of thing, today shouldn't be too difficult. So we'll run through a couple of problems there. Okay. Then tomorrow you have your quiz over stoichiometry. It is an open note quiz, but it is not a partner quiz. So you'll take that on your own. You'll get your periodic table. You'll get your your calculator, obviously, something to write with. Then you'll have your quiz. Quiz is 5 problems, 5 calculation problems. That's all it is. Okay? There are no multiple choice. There are no short answers. Just practice calculation problems. Yes, sir. 23, maybe, something like that. Low 20. So I can't remember exactly off the top of the head. 7, 5, 12, 18, 24. And then on Friday, you'll have a chance to ask me questions regarding any kind of review for semester exam that you might have. As we've said on multiple occasions, semester exam is only second semester exam, so it only deals with chemistry stuff. I believe I gave you guys your tests yesterday if you wanted to take them. If you didn't grab them or if you weren't here, see me after class and I will give them to you. Yes, sir.
When do you think you'll have the lab reports?
I am a good chunk into them right now. I don't know if I'm going to get them done before I leave today, but definitely early tomorrow. Okay. So, yeah, they will be up. If not tonight, then probably early tomorrow.
Okay.
Like you just answered it, but I just said they were going to be up tomorrow.
That's what I always put something.
No, I'm saying it's going to be.
And then we're looking at your guys' exam Monday morning. I think I told you guys, I'm pretty sure I told you guys about my situation with the federal government. So, that I got called for jury duty. Although I did talk to my girl Natalie at the jury department yesterday. Yeah. No, she's some girl that works at the jury department. I explained to her the situation, and she said, "Call me on Friday. I'll let you know what's going on." So there you go. So there is a good chance I will be here on Monday when you take your exam, but I can't guarantee it 100%. Okay. Yes, sir.
I heard that when you in your review class, someone said last
No comments. Shall remain nameless.
Sorry for the Peter.
All right. Yesterday. Come on. Well, this is science. Okay. Yesterday, I believe right at the end of class, we started work on number 4 of your problem set. Is that correct? Okay. But we didn't quite get through it, if I remember correctly. Okay. The whole back of the page is totally blank.
No, it's not.
Fantastic 4 back there. Which one's Chris? All right. Yesterday, we started up a new kind of problem. On Friday, we talked about the first type of stoichiometry problem, and that was the mole-mole relationship. And we said that we can compare moles of something in a reaction to moles of something else in a reaction through what? what do we use to compare different parts of a reaction? Charlie? The coefficients from our balanced equation. And we make them into what? What do we call that thing that we made them into?
Mole ratio.
The mole ratio. If I give you information in moles, all you need to do is you need to just do the mole ratio to convert it into moles of something else. But yesterday, we introduced a problem where, okay, in this problem, we started off with something in moles, right? 2 moles of magnesium, but the question was asking us for something in grams. So we had to go one extra step to get where we wanted to go. With that being said, let's take a look at number 4 on that worksheet. Like I said, I know we started it in class yesterday, but let's work it from the beginning just so we can see the whole process. So, cellular respiration involves the combustion of hydrocarbon glucose, which is C6H12O6. How many moles of water are produced by the respiration of 90.1 grams of glucose? So first things first, how do we start problems in this chapter? Maxie,
What are we looking for?
what are you looking for in this problem, Maxie?
How many moles of water?
Okay.
And,
Moles of H2O, right?
what-
Then, next step, what do we have to work with, right? So in this case here, it gave us that we want to respirate, I think that's the right word, 90.1 grams of glucose, C6H12O6. But we said that in the what do we have to work with category, we always need to have what? Balanced equation. I told you that I would give you at least the equation itself, not balanced, on the test. You would need to balance it. So, because this is a combustion reaction, we know that it has to react with O2. Because this is a hydrocarbon, we always get 2 products out of that, CO2 and H2O. And I believe yesterday I balanced it for you, correct? Right.
6, 6, 6.
There's 6 here, there's 6 here, and there's 6 here. Okay? So then we started off this problem. We said this problem, being a conversion factor problem, starts the way all conversion factor problems start. So we start with our number that has a bad unit. So 90.1 grams of glucose, C6H12O6. Then, we do conversion factor, right? Time sign, fraction bar. Then, what unit's going on the bottom of this conversion factor? But we said that we couldn't just do this, right? That's not allowed. We can't compare grams of one thing to moles of something else, right? Why? Morgan, go ahead. They're not the same. That's true. How come we can compare moles to moles but not grams to moles? Chris, did you want to throw it out there? When we compare moles to moles, we know we're always talking about the same number of atoms. When we compare grams to grams, that number may change because not every atom is the same weight, right? Different atoms weigh different amounts. So if I weigh out 5 grams of one kind of atom, 5 grams of another kind of atom, because they're different sizes, that might not be the same number of atoms. But moles, we always know is the same number. So, first thing we had to do in this problem was, we can't go there, right? Go ahead, Tony. So we're going to go moles of glucose here. Okay? When we're converting something from grams of one thing to moles of that same thing, right? Moles always gets a 1 in front of it. What number goes here? Where do we get this number from? That's the, what? Not the atomic mass, because it's not just an atom anymore, right? It's the formula mass, okay? And sometimes we also refer to it as the molar mass, right? And I think, did we calculate that yesterday? Okay, all right. So, how are we going to calculate the formula mass for this compound? So 6 times 12.01, right? Because what's 12.01? That's our mass of carbon, right? And Tom, how are we going after that? Okay, how many hydrogens are there? 12 hydrogens, right? So 12 times 1.01, I think is what your periodic table says. Okay. And then, what else? 6 times the mass of oxygen, which I think yours is 16, right? Okay. What? So we plug that in there, we get 180.18. Okay? Now, though, right, does this give us what we're looking for? No, because we said we're looking for moles of water. So, another conversion factor. What's going on the bottom of this conversion factor? Moles of glucose here, right? 6681206. And then what's going to go on the top here? When we have a conversion factor that's comparing moles of one thing in that equation to moles of another thing in that equation, where do we get these numbers from? That's where we get our coefficients, right? Nothing in front of glucose, that's glucose of 1, 6 in front of water. Then mathematically, we know we can put that over 1 and turn it into a fraction. Now we're multiplying 3 fractions together, right? Units-wise, grams of glucose on the top, grams of glucose on the bottom. Moles of glucose on the top, moles of glucose on the bottom. What? So units-wise, everything cancels except for what? Moles of water, right? And that's what we're looking for. So now, multiply 90.1 times 1 times 6 divided by 1 times 180.18 times 1. When you do that, you should get 3 moles of water. Are we good there? Do we need a couple seconds to finish running it through calculus?
Right here.
Yes. No, I wasn't giving you that mean look. I was giving Austin and Trish that mean look because they can't keep their hands on the faucet. Yes.
I'm sure it's going to be fun.
On the semester exam, yeah. I mean, we've done 4 days of stoichiometry. You know, there's only going to be one stoichiometry on the semester exam. Yeah, I'll give you the equation for that. Why don't we finish up the last kind of problem?